Say we're starting 6.5 applications of common logarithms. Yeah, we're still dealing with logs. I have 5 to the x equals 62. So the use of calculators, you really don't need to know everything about logs as much anymore. How can I change this one? I can change it in log form. What would it be in log form? Okay. Say it again. Log base 5 of 62 is what x is. That works great, but can you solve it? 5 to the what is 62? Well, there is something, but it's not a whole number. That's if I have it to the 5th power. All right, so you're saying take the log. Log base 5 of 5 to the x equals log base 5 of 62. Actually, sorry. I'm showing you this method. What did I do to this problem? I did the log to both sides. What base is that log? 10. What does it mean when I have an exponent inside of a log? Where does it belong? I can put it out front. So this really can be written as x log 5 equals log 62. What am I trying to solve for here? Trying to solve for x. What would you do to get x by itself? So I'm going to divide by log 5. X equals log 62 over log 5. And the calculator, log 62, close the parenthesis, actually I hit it twice, divided by log of 5, close the parenthesis. And it is about 2.56. If this was 3 to the x? All right, so you're saying if I had this problem, except for now I have 3 to the x. Really, I'm going to change this to a 3, so this changes to a 3, which changes this to a 3, which changes this to a 3. It would be log 62 over log 3. You're thinking of log base 5, of rewriting it. Log base 5 of 62 is what x is. Then in our calculators, we can't do log base 5. Up to now, I've said you can't solve these problems. The only thing you can do is leave them like this. Now we're... You guys are moving a little bit faster. Let's look at the first one. Let's look at the first one. 7.5 to the x equals 39. I can really take the log of 7.5 to the x equals log of 39. Whatever I did to one side, I did to the other. The x goes out front. So x log of 7.5 equals log of 39. Divided over log of 39 over log of 7.5. Would have been faster for me just to type it. It's about 1.82. Do you see how we did this? Okay. How about the next one? Okay. Yes, I can. How can I write it? How can I write it? Log 9 to the negative x equals log of 0.012. Negative x, log 9, still divide. So negative x equals log 0.012 over log of 9. But do I want to know what negative x is? So I'm going to make the negative over here, get rid of it over here. Yep. So it's negative log 0.012 divided by the log of 9, which is about 2.01. Are they becoming easier? I'm going to show you a faster way. Someone has already found out the pattern, I'm sure.
Darren, you found out the pattern yet? I told y'all don't listen. What you said? I'm sorry. Oh my God, do y'all see the problem? 39 is going to divide 7.5. Yeah, that's what I am.
Okay, so I'm just going to jump. If I have log base b of x, I have any base, log base 5, log base 10, log base 50, I can change it to base 10 easily. All I have to do is log base 10, that's what we want, of whatever it was equal to over log base 10 of whatever the original base was. This is how you change bases.
Why is something always not equal to 1? Oh my God.
Why? Why did I keep saying it can't be equal to 1? Okay, a is 1. Can I have base 1? No. That's why. Plus, can I take the log of 1 is 0. Can I divide by 0? That's why. Yes.
And x has to be greater than log a.
Is that better? Yes. All right. Remember, once you guys have this written down, I'm going to go back to that first problem. All right? Going back to the original problem. We already know the answers about 2.56. We could rewrite this as log base 5 of 62 is what x is, right? But I want it to be in log base 10. So I take log of 62 over log of 5. Isn't that what we did before? The log of 62 divided by the log of 5. before we could not solve these problems. You don't have to go through all the algebra. Do you understand how I did that algebra? The rearranging.
You just took the,
Right. All I'm doing, this is a formula, it cuts out that algebra part. If I have something in exponential I cannot solve, that's your base. The base goes on the bottom, this goes on the top. And that's it. How about if I had these two problems? See, automatically you see these problems, and go, I can't do these because they're different. What's my first step on the top one? Subtract 2. 5x equals. How do I solve it from here? Log. This is where you need to be careful on the little stuff. Log of 358 over log of 5. No, can't say larger number. The base of the exponential goes on the base of the fraction. Log 358 divided by log 5.
do you have to close the parentheses?
That's what I'm going to just show you. This is about 3.65. Deshonda asked what happens if I don't close it? Do I get the same answer? No, because what the calculator is doing, it's saying, I'm going to take 358 divided by the log of 5 and then take the log of it. You have to be careful about writing the parentheses. Always close parentheses. Leash. Yeah, it won't show up as an error because it's only as smart as what you type in. I can do that, just not what you want it to do. Felicia.
Can I go over it on 3.654?
Yeah. If you went out thousandths, that's fine. This one. Okay, just look at it. How can I solve it like this?
Well, it's all based in English.
It's basically just negative x. We already did a problem like that. Let's do the log of x.
Someone said this. What's log base 10 of 10? 1. You're jumping ahead. I don't care what this was up here. It could be a whole long string up here. Same thing as having an x. So I'm left with x minus 1 equals log of 556 over, and you already told me log base 10 of 10 is 1. So the only thing I really care about is the log of 546. And I get, no, x minus 1 equals 2.74. Now what do I need to do? Add 1. X is, it sounds dumb that I said what's adding on 1, but I still see people doing this. Add over 1, my answer is 2.75. It's stuff that you're not careful about, the dumb stuff. The next thing we're going to do, write log base 4 of 20 as a base 7 expression. Using the change of base formula. We're going to change something in in base 4 to base 7. I want to change the bases.
So where you at log base 7 to 20? The birthday's on the 9th.
Long base 7.
Okay, there's the formula. I want it as base 7. So it's base 7 of what? Okay. So I have this, and I want it to be as base 7.
So which one would be it? Which one would be it? It's 4. No. So 4 should be B.
Which one is it in?
It's in base 4.
It's in base 4. So I'm going to have log of, okay, log,
Oh, okay.
and we want 7, right? I know you can't do this on the calculator. And we know it's going to, actually,
Whoa, A gotta be the same number.
That's what I was saying. So the X has to be different. Mr. Man.
I put it in the,
Cheese and rice. I knew it. I could have told y'all this because I know it's home time. We saw Perry Clapton. It's 5. Are you ready? Is that right? And what was the that? Just 20 divided by 4. Oh. This log base.
we changed,